In this video, I'm going to go over z-scores, how to calculate them using the undergrad statistics data set. And I'm going to particularly go over three different types of calculations that we can do that all utilize a z-score. The first is going to be given a particular observation, how many standard deviations away from a particular mean is a particular is that score, or in other words, how many z-scores away from the mean is a score is a particular score. Given a particular score, what is the second calculation we're going to do is given a particular score, what is the proportion of observations that fall above or below, or above or between two different scores. And then finally, given a particular percentile, calculate a predicted z-score. Or, excuse me, calculate a predicted, not a z-score, a regular score. For steps 2 and 3, are these two different types of questions. I'm going to highly recommend that we use the z-score stats app that's linked next to this video. That's going to, I think, really help you visualize what's going on when we're doing these z-scores. So we're going to start with number 1, and just this is a particularly tricky topic to explain. It may not seem that relevant to some of the things that we're going to be doing, but when we get to the sections of the statistics where we start talking about p-values, a good understanding of z-scores will help us kind of translate our knowledge of proportions and percentiles to this z-scores. Or our knowledge of z-scores will help us understand how p-values are calculated and what they actually mean. So for this first one, given a particular observation, how many standard deviations away from a mean is a particular score, let's go and pull up, let's first look at the formula for a z-score. So I want you to ignore the formula on the right side of the screen and just focus on this formula that I'm highlighting here. So just focus on this formula right here. We have a z is equal to x, and x in this case is a particular observation minus the mean divided by the standard deviation. So a pretty simple formula. So let's go ahead and take that and formula and actually use it to calculate this first kind of task that we'll have to do. So let's go ahead and open up the undergrad undergrad characteristics data set. And let's start with observation 16, and we'll go to conscientiousness. So we could say for person 16, which I'll highlight the entire row, for this particular score of 54 for conscientiousness, how many standard deviations away from the mean is this particular score? So what we're going to want to do is create a new sheet where we're going to make these calculations. So let's first pull the value, and actually let's make this a bit bigger to help you out. All right, so let's go and pull the value from the previous spreadsheet. So we're going to hit equals here, and we're going to go from observation 16, or person 16, and we want to measure conscientiousness. So we're just going to say that cell equals this observation. We'll hit enter, and we see that 54 here. We'll just maybe put person here. We'll say 16, that's the person. The variable is conscientiousness. So I'll just copy that one, Control C, and then Control V and put it there. All right. So what we want to do first is we probably want to calculate the mean for conscientiousness. So let's go ahead and calculate that. So we're going to go ahead equals. We'll type average. We'll click data. We are going to select this entire column, and even though that this first row I think has text in it, it'll ignore this first row and it'll just work with a number, so I don't think we have to worry about that. So let's go ahead and enter, and we get a mean of 58. Let's increase the number of decimal points to 57.52. And now we're going to, so that's our mean. Now we also, if we go back to this calculation, we also need to know the standard deviation. So we have x, which we have as 54. Our mean is 57.52. Now we got to calculate the standard deviation. So we'll make another column here that's called standard deviation. We'll hit equals. We'll type S, get our standard deviation. Go back over to data. We'll select the whole entire column, and we'll hit enter. So we get a standard deviation of 14.82. Let's round to the hundredth. And we're almost there. So now what we're going to have to do is calculate the z-score. So we're going to put what we just see right here into a formula: observation, the average divided, and this difference divided by the standard deviation. So let's go back to here. We're going to hit equals. We're going to take our observed score of 54. We're going to subtract it from the mean. We're going to have to put parentheses to get the order of operations, because we want to subdivide the standard deviation divided by the difference and not just divided by the mean. So if we don't put these parentheses, it's critically important. So what we get is a z-score of negative 0.24 rounded to the hundredth. So this is 0.24 standard deviations below the mean. A score of 54 is. So that is how we accomplish the first task in calculating a z-score. But oftentimes we want to know, given a particular score, what is the proportion of observations that fall, let's say, below a particular score, or above a particular score, or between two scores. So now we're going to jump to that. So let's go ahead and we'll stay on, we'll go back to the data set. We're going to stay with this conscientiousness, but we're going to pull a different person. And recall, if I pull down here, I should, oh, no, not there. If I pull down here, this is going to pull from the data set, should be person 17. So if we look down here, 16 was 54, 17 is 52. And so maybe let's go with someone a little bit further away. So let's pull down, get a few more observations here. Let's look at this 91. That's super high. Who is that? That is 91 is person number 20. All right, whoops, not quite there for that yet. So we're going to put 20 here, and this is the one we're going to calculate. So we want to get this person, the mean should be the same. So we're going to, if we remember, we're going to hit F4, we're going to anchor the cell here. We don't really have to do that since it involves the entire row, so but we'll just pull that down. This again, we're going to anchor by hitting F4, and then we're going to pull this all the way down. And with this, we're not going to want to anchor. We're going to want to keep this all relative, so we'll pull this down. And actually, we've calculated z-scores for each of these individuals. Now, so this is individual 17, 17, 18, 19, and 20. And we can see that this particular person, 91, is 2.26 standard deviations above the mean. Now, what we need to do, and the question might be, what is the percentage of people that fall, or proportion of people that fall below this? And so we're going to pull up a stats applet that I think really helps app that really helps kind of visualize this. So here we have the normal distribution. You can see the sort of bell-shaped curve. In the middle of this distribution is 0. You can kind of see that right here in the middle. And then -1 and 1 above, these correspond to 1 standard deviation above and below the mean. And so what we're going to do is we're going to say, okay, we want to know what proportion of individuals fall below this 2.26. So we're going to take this applet, we're going to move the far left kind of slider all the way to the left, and we're going to move this to where this circle around the cursors is around the top number. This is the z-score, corresponds to the horizontal axis. This number right here is the proportion of individuals that are shaded in the sort of orangish yellow color. So as I slide this, gets higher and higher, we're getting up to 2.26. We're just above it. And we are, let's see if I can incrementally, that's about as 2.2, that's about as close as we can get. So about 98 or 99%, if we round to the 100th, percent of individuals fall below 2.26 standard deviations below or above the mean, excuse me. So 98% of, or proportion, or 98%, excuse me, of individuals fall below 2.26 standard deviations above the mean. That kind of signifies that this observation is really high compared to the rest of the data. So we could go back and look at maybe this individual is negative 0.03, so he's right near the middle. He's kind of right around there. So 48, almost 49% of individuals fall below that. If we wanted to calculate the proportion of individuals that was above a particular z-score, let's say we wanted to calculate the proportion of individuals that was above negative 0.24, well, we're just going to kind of shift the slider. So we're going to pull this one all the way to the right, and we're going to move this, how far did we say? Negative 0.24. So we are there. So we can say about 60% of individuals, or 0.59 or 0.596, or if we're rounding to the 100th, 0.60 of individuals fall above negative 0.243 standard deviations below the mean. So finally, we might be asked, okay, well, what proportion of individuals, let's say, fall between a score of 40 and 91? So if we just look at these two rows right here, and we say, okay, negative 1.18 for one slider and 2.26, what proportion of individuals fall between that? So we move this, what was that, negative 1.18? Negative 1.18 and 2.26. There we go. And we can say that we can see that 8.87 or 87% of individuals fall between these two scores. Now, oftentimes in the book it shows you using tables for this. I really like these interactive sliders because you can see the proportions move as you slide slide the z-scores along the x-axis or the horizontal axis. So I really find that this is really helpful for visualizing what's actually going on. So finally, the last kind of demonstration I want to do in this video is, given a particular percentile, calculate a predicted score. And that predicted score is not a z-score, but a predicted score on the actual scale of measurement that you're doing. So if that's conscientiousness or extroversion, it's on that scale. So if we go back to our equations, we're going to ignore this equation on the left because this is what's trying to give us the z-score, and we're going to use this equation on the right. This equation on the right tells us it's basically just another algebraic. You doing a little bit of algebra, you solve for x using the z-score, the standard deviation, plus the mean. So let's go and see how this actually comes about. So we'll go back to the data set and say we want to calculate, we're not going to use individual persons, but we want to calculate someone at the 87th percentile. What is that predicted score? So the 87th percentile, if we go to the stats applet, we click on this, the percentiles go from left to right. So if we move, if we see right here, there's it's starting really low and we're going up. So this is if we look at, focus on this number right here, this is about the 9th percentile. This is the 50th percentile. This is about the 85th percentile, so on and so forth. So let's say we want to find what is the predicted score for conscientiousness at the 87th percentile. So first thing we're going to want to do is go to this applet. We're going to want to figure out what the z-score is at the 87th percentile. So now we're focused on this number, the proportion number, and we're going to go to 87th percentile, and we can see we get a z-score of about 1.129. So we're going to take the z-score of 1.129 and we're going to write that, we'll just put that here, percentile, and we get a z-score of 1.29. And remember, our mean is still the same. The mean is, I'm just going to write that in, 57.52, and our standard deviation is 14.82. So we want to determine our predicted x, and this is our standard deviation, and this is our mean. All right, so we're going to click on this box. We're going to say, and we're going to go look at that formula just so we jog our memory. It's z times standard deviation plus the mean. So we're going to go z times standard deviation. We're going to add the mean, and we get a predicted score of 76.64. Whoops. So that is their predicted score at the 87th percentile. Just to show you one more, if we wanted to figure out the predicted score at, let's say, the 20th percentile, let's move this all the way over till this value is as close as we can get to 20. No, that's good enough. We get negative 0.829. So we're going to type this in, negative 0.829. We're going to use the same mean. Pull this down, and we're going to pull this down, and that's going to give us a predicted score of 45.23. So that is how we, what was the percentile? I'll just put this in here, 20th. So in this video we've covered how to perform kind of 3 different calculations using these z-scores. Again, read through the chapter. This will make a little bit more sense why we're doing all this, but this will make even more sense as we start getting more into p-values and statistical inference.